Welcome to LeetCode Solver, and I am a LeetCode Solver. Today we are going to solve the 16th problem in LeetCode 30-day challenge. Well, the problem is valid parenthesis string. So today also I'm going to open the problem and I'm going to explain the problem and explain my thought process as well as the idea generation process. Let's open the problem. Valid parenthesis string. Given a string consisting of containing only three types of characters, left bracket, right bracket, and star, write a function to check whether this string is valid. We define the validity of the string as follows. Any parenthesis left bracket must have corresponding right bracket. Any right parenthesis must have a corresponding left parenthesis. Left parenthesis must go before the corresponding right parenthesis. Okay, star could be treated as a single right parenthesis or single left parenthesis or an empty string. Okay, star can be anything, either empty string or left or right parenthesis. An empty string is also valid. Okay, well, how to solve the problem? The star will be there, which can be converted to left or right parenthesis or empty. Okay, here this is true because this is a valid uh, parenthesis sequence, and this is also valid because if we convert this star to empty string then it will be valid. This is also valid because we can convert this to left one. So if there is star, then there are several options available. Based upon these options, the decision may be different. If we choose this as a empty, then the as a whole bracket sequence is not a valid one. But if we choose this as a left bracket, then this will be valid bracket sequence, so it answer will be true. Okay, what I'm thinking right now is whenever we get star, we have option to make it either left bracket or right bracket or empty, nothing. So I'm thinking like whether we can do a recursion or backtrack, and we will traverse the string, and whenever we find the current position value is star, then we will apply several options and we will do the recursion, and the recursive call which leads us to the valid sequence will be our answer. If I do this, then the best case, when the best case will arise, the best case will arise when we traverse whole sequence and we also maintain the validity is also maintained. Okay, how can we check validity then? So while traversing, whenever I get these ones, whenever I get these ones, then I need to have some kind of right bracket sequence in the right side in order to make it valid. But if while traversing, if we find several right bracket, like there already three right bracket, one left bracket, this is already matched, and we are getting right bracket, but no any left bracket before the right bracket, then this already uh, violates our uh, validity of the parenthesis. So this will not lead us to the end of the string. So if we reach to the end maintaining validity, then that will be a uh, that check will determine whether the given the string we formed is valid or not. So say for example, if we have this, the last example, this. Now while populating, while doing backtrack, we come into this position and we see that let's maintain a variable which is also open bracket open bracket is 1, which is fine. Initially open bracket is 0. Whenever we get this, then open bracket is 1. And for star case, the recursive call, maybe we apply the recursive call with the three different options. One with the it will goes like this, and in this case the open bracket will be, we are also maintaining open bracket will be 2, and if the case is like this, yeah, then open bracket will be 0. Open bracket is the one open bracket is already balanced by another closed bracket, so the open bracket count is 0. And if we do not care, like we simply ignore star, then the condition is we have one open bracket, simply like this. So these three conditions may arise, and uh, these three steps will also lead us to different stages. So let's go with the first one. In this choice, and the another choice will be this one, and here the open bracket count will be decreased by 1. So the first one, this one will be balanced by this one. So it will be simply like this after the balance. And in this case, there will be this one. And we see that while forming this, while going to this position, we already noticed that we have 0 open bracket and the current bracket is closed bracket. So while we have 0 open bracket, we cannot have any closed bracket. So this recursive call will not lead us till the end. So we will simply ignore these calls and we will move forward. So that call will be vanished. And for this case, we will have something like this, and balanced count will be this 0. Open bracket will be 0, already balanced. Now in this case, let's go with this case. In this case, we were almost there, like we're maintaining up to this. Now the another bracket will be there, and that another bracket uh, will balance the open bracket. So the overall open bracket count is now balanced and it becomes 0. So if we reach the till the end, as well as our open bracket count is 0, that means every open bracket are wisely balanced by close bracket. So this recursive call give us the true, I mean it will tell us that this is a valid string. This is a valid parenthesis string. So this true recursive call will now propagate to its parent, and this will also propagate to its parent. So the in recursive calls we have a term like the one which give calls to the different calls, like this is the one root call, and this call will give call to the different sub calls. So the one which is responsible for giving calls is parent, and the ones which are getting calls after that level will be treated as a child. And so here it will give calls to the parent and the as a true. So if any of the child tell the parent that any of this is true, then the parent itself will be true. So in this way, the recursive call will, the we can maintain the recursive calls. And if from current position, if we are getting any of the uh, children give us true, then the recursive call as a whole will be true. So in this way, we can check the validity. But here we see that given the constant that like it will be up to 100, then like in each position, if it is star, then we have several options, like either to put left or to put right or to put do nothing. So we have three different options in each level in the worst case. So if the length of the string is n, then in each steps of the string we have three different calls. So we will give calls to the three different children, three recursive calls, so which will be up to n times. So which which will give us the complexity of 3 to the power n if we apply this approach. So this time complexity would be there. So if we think about the value of n, 3 to the power 100 is huge, so which we cannot hold, we cannot run efficiently if we apply this solution. But this solution will work if the size of the string is very small. Now let's think some better solution. Now if we think about the better solution, we can think about like if we maintain the state of these things, whatever we did here in a vector in some array, like the position, in which position or index we are working on, and how many count of open bracket, and we can simply say open bracket count. If we have these two things, then if we put if we cache the value that we will get if we have these things, then the several calls will can be optimized. So whatever calls we made in each steps, that calls can be simply be traced if we have these two things available. So if we have index and open bracket count, then we can simply store the result of these things either true or false. Then We do not need to calculate again if we found the same thing via some recursive calls. So total index can be, in this case, like if the n is 100, then total index can be 1 up to 100, and open bracket count can be up to 100. So if we have a matrix which of this size and which stores the different result, and then we can simply return if we get similar call again. So in this way we can cache the result, and we can cache the result of recursive call to this matrix, so that we do not need to give recursive calls again and again. So in this way we can optimize our initial solution. So let's go for the implementation. Okay, I define the array size as n. If we do this, then the time complexity would be, as I defined already, is big O of n square, and space complexity is also same, because we are storing in a matrix of n by n. So yeah, let's define a vector dp dynamic programming. So this kind of calculation is also called dynamic programming. So let's store this in dp vector, which is actually a vector, 2D vector, which is equal to n cross n, and everything can be, initially we can think about making everything as -1, or we do not need to store. Okay, let's store -1. Now let's think about how we can formulate the recursive call. So we can give a name of the recursive call as a solve, which will solve the problem, or yeah, or we can give a better name as well. Let's simply put as a solve for now, and we will pass three things actually. We need to know the string. Let's pass the required variables first. We need to know the index, so current index, and we need to know the open bracket count 0. And now let's put variables, like we need to have a string and we need to have dp, and let's say we'll store 0 and 1 as a true and false. So let's store solve, which will takes index and which also take open bracket count, say open count, and string, we can pass string as a reference, as a memory, so we don't need to copy the whole things again and again. Also we can pass the vector as a reference as well. Now the best condition is if we reach to the index is equals to the state size, then we will return true. That means we can form a valid parenthesis. Otherwise we will if we already calculated the result like the index and open count, if it is already calculated then it won't be -1. Initially it is -1. So if it is not -1 then it has already been calculated. So in this case we will return dp of index and open count. Now we have different options based upon what is the value of the current index. So if current index is this left bracket, the options we have is index open count. Option we have is simply incrementing the solve. We will go to the next index for sure, and we will also increment the open count by 1, and string will be same, dp will be same, and if it is not left bracket but it is right bracket, then what we will do, we will simply do the same thing. Index will be increased, open count will be decreased by 1, but keep in mind that if open count is already 0 then we cannot give this call, so we have to check this. We can also check this over here as well. This is essential condition. If open count is less than 0, will return false. Now the another essential condition is if it is star. So according to the problem there will be only 3 characters. So if it is star, so then we have 3 different options. dp of index open count will be if any of the recursive call will give us the true, then it will be true. So we can maintain the or condition over here. Yeah, let's do something similar, and or will interpret it as a finally we will interpret or as a boolean value as a integer, so which will be turned into 1. So true will be turned into 1, false will be turned into 0. So if anyone is 1 then we will return 1, we will store 1, and finally we will return dp of index open count. So let's make 3 different cases. Case for left case taking left bracket. If we take less bracket, then what will happen? Solve index will be always increased, and open count will also be incremented. Yes, and dp will be same. This is the value we will get. And case taking right, we can take right as well. In this case, if we take right, also index is always incrementing, count will be decreased, and dp. And case ignore, we can also ignore. So in this case, the index is still incrementing, open count will remain same, and dp is there. So if any of this case taking left or case taking right or case ignore, if all of them are 0, then this OR condition will give us 0, and if any one of them is greater than 0, then this OR condition will give us 1. Okay, and we will finally return this. Open count looks good to me. Let's go through the code again. We define the dp with vectorial size n by n, and every value is -1, and we give a recursive calls with cache implementation. I mean memorized recursive call, memorized. And here we see if open count is less than 0, we are returning 0. If it reach up to the int, then we are simply saying that this is a true, and this is a true, and this is a valid bracket sequence, and we are returning 1. And if we already cast it, if it is not -1, then we already cast it, then we will return the cast value. We will not go through any recursive calls again. And otherwise, if it is a left bracket sequence, then we are incrementing this. We are always going to next index, but we are also incrementing this and passing this and this together. If it is this, then we are decrementing this and passing this and this together. And if in other cases, we are doing 3 different cases. For left, we are incrementing. For right, we are decrementing, and for the case we are ignoring. And this open count should be 0 at the end. If it reaches to the end, and if open count is 0, then everything is balanced. In that case, we will return 1, else we will return 0. So this is not balanced. Okay, all right. And then after we are returning this cast. Seems good to me. Let's run the case, run the code. Compiles an error. Okay. Alright, let's submit the problem. Let's try with the different test cases. It should be true. This should be true. This should be true as well. This should be false. This should be true. Okay, alright. Let's submit the problem then. Alright, accepted. Let's see more details. Well, the first solution that I mentioned earlier, which is doing recursion and backtrack, is the same thing that if we do not store the end result in a DP, like we are storing end result in a DP, instead of storing here in this matrix of n cross n matrix, we can simply return this so that it will be a recursive call without storing anything. So that case will be a recursion, pure recursion and backtrack. Uh, and if we store the end result, then we can say this is a dynamic programming solution, which is caching the end result in a matrix. So basically, dynamic programming or caching or memoizing is nothing, which is just simply storing the end result of recursion so that we do not have to calculate again and again for the same subproblems that may arise after recursive calls. So in this way, we solve the problem, and yes, uh, I already explained time and space complexity. Time complexity is big O of n square, and space complexity is big O of n square as well, and some extra space because of the recursive stacks. So, but big O of n square will uh, overcome and the extra space, the space used by recursive stacks. So, so yeah, this is time and space complexity. Anyway, thank you so much for watching this video, and if you would like to see similar video, and if you would like to know how to participate and how to solve the problem in real coding interviews, please feel free to subscribe this channel, and also comment your idea. If you have different approach for solving this problem, please feel free to share. And yeah, thank you so much for watching this video, and hope you enjoy the video. And if you have any comments, please feel free to comment. And yeah, have a nice day. Bye bye.